Well, hi again, this is Bob, and I'm over on page 374. We're going to finish off. I've got a couple of other examples to look at with regard to using our interval formula. And I thought we'd start off by taking a look at example 7.2. This is just for practice, and it'll give us a little more experience in using the formula. And 7.2 talks about the number of patients, and we have an urgent care center that has 4 doctors, and it says they can see an average of 18 patients per hour. That's our sample mean. And it says that we have a known standard deviation of 3.2 patients per hour. And we have a random sample of 42 hours. This is the way most of these questions are going to break down. They're going to give us the sample mean and the known standard deviation and the sample size. And they're going to also give us the 99th. In this case, we want to find the our confidence level is 99%, which means alpha of 0.01. And so we want to set up the 99th confidence interval around the mean, or of the mean. And you may recall for an alpha of 0.01, which is the same as our 99% confidence, that our z sub alpha over 2 is 2.58. So if you look at the example there, you will see that they give us all the values that we need for us to go and use the formula. Unfortunately, my pen is not cooperating again, so I'll try it below, cross this out. So we have our sample mean of 18. And to that, we're going to be adding 2.58 times our standard deviation of 3.2. Darn it. Over our sample size of 42. That's a pretty good sample size. So there's our correction on the right in order to be 99% confident. And then on the left, we'll have 18 minus 2.58. Same exact setup, except we'll be subtracting. And again, I stress, or can't stress enough, the fact that you actually work this out and make sure that you understand the order of operations on your calculator, and make sure that you use that calculator when the test rolls around. Anyway, we end up with a confidence interval. In other words, we can be 99% confident that the true mean, based on those values they gave us, lies between rounded 17 and 19 patients per hour. Now, notice this isn't a huge amount. We're not adding a huge amount to our sample mean. It's almost like a little correction on that, but we are now having this interval. We're 99% confident that the sample mean indeed falls, or excuse me, that our population mean indeed falls between 17 and 19 patients per hour that can be seen. Remember, though, that this is still a probability, and there's still a 1% chance that we're off on our answer. Anyway, I wanted to very carefully, because it has something to do with where we're getting these values. Remember, the 3 values were like 1.65, and that's represented the 90th confidence interval, and 1.96, these are our z sub alpha over 2 values for our to be 95% sure. And our last one was 2.58, is our 99th when we want it to be 99% confident of the interval. And I tried to explain where these values came from and how the alphas are related to each other. But let's say, and that's why I wanted to do example 7.4, this is not a confidence interval that we normally use, but it could be used. It could be used. But the reason I'm doing it is I wanted to show, actually it's figure 7.4, not example 7.4. Let's say that somebody wanted to set up a confidence interval using the to be 98% confident, okay? And these are the values for the three most accepted or widely used ones, but I'm only doing this again to show how we would arrive at the z sub alpha over 2 value. And the first thing you would do is you would go 1 minus 0.98, and that would give you 0.02, and so alpha then would equal 0.02. Now, in order for us to get our value to use in the formula, we've got to find out what alpha over 2 is. So we would simply take the 0.02, which is alpha, and divide it by 2, and we get alpha over 2 is 0.01. So here's the situation that we would have. Okay, now we know that the majority of our sample means are going to fall in this particular situation. The area, of course, that we're interested for the sample means fall in would be the 98%. That's our confidence part of the graph there that I've shaded. In other words, it's the hump of the bell. And then recall that 0.01 of the graph would be in the right tail and 0.01 in the graph would be in the left tail. Now, what we want to do is we want to find out the, now we're going back to using the tables again. There is a z value associated with that tail there. It's actually our z sub alpha over 2 value. And what, if you notice, what we've got, and this is how our z tables work, everything, we're just finding the z table value now. Don't worry about the fact that that's 0.01 there. The way that we would do that is we would recognize that we have 0.01 of the graph right there, and then 0.98 and 0.01 to the left of it. So what we've basically got is this situation here, 0.01 and 0.99. This is only to find the z sub alpha over 2 value. Okay, notice what the book did, and to find the z sub alpha over 2 value, they went into the tables and they found the closest value to 0.99, which was 0.9901, and when they went up, they came to 0.03, and when they went over, they came to 2.3. And that means that the z sub alpha over 2 value for the 98% confidence interval would be 2.33. Okay, let's finish off the idea of using the confidence interval by looking at example 7.3. And again, this is just practice setting up and talking about where things came from. Now, this is raw data, so we're supposed to, according to their rounding rule, when we're dealing with raw data, round off to one more decimal place than the places in the original data. And the places in the original data appear to be to the hundreds, so we will be rounding off to the thousands. And I should mention that the book doesn't always follow its own rounding values, but we're interested in the formula rather than the hard and fast rules on rounding. Anyway, this is credit union assets, and these are in millions of dollars, and they found that if we ran those numbers, the sample mean turned out to be 11.091. Of course, that's in millions of dollars. And the sample size there was 30. Fortunately, they did the, now this will be, in this case, our, just lost my place here real quick. Now that turns out to be, it looks like the entire population, or they have the standard deviation, which is lost my place here, 14.405. Okay, so we're ready to set up, but notice that they wanted the 90th confidence interval. Since the 90% confidence interval is to be used, and I'll follow this, we don't need to do this. We already know the answer is 1.65, but notice that they went 1 minus 0.90 and got 0.10 for alpha. And notice when they took that 0.10 and divided by 2, they got 0.05. And when they went to the tables and found out the value, as I've shown before, they ended up with 1.65 for our alpha. So we're now ready to set up this question with the information that they've given us. Don't know why this pin keeps giving out here. So we had our sample mean of 11.091, and to that we're going to add 1.65 times our standard deviation of 14.405 divided by the root of our sample size of 30. The formula really is pretty straightforward to use after we get used to it. I'm going to have to squeeze this in a little bit here. Fortunately, you can follow along, and we end up, after you work through the calculations, with the true, or we say we believe, or we're 90% confident that the population mean lies between 15.430, one more decimal place than they gave us, and 6.752 millions of dollars. Okay, in fact, I'll summarize with a reading. Hence, one can be 90% confident that the population mean of the assets of all credit unions is between 6.752 million and 15.430 million, based on a sample of 30 credit unions. All right. Well, the last thing we're going to look at is another pretty straightforward formula. You may recall I mentioned early that the error is defined as, and this is from the first lesson, this is the correction that we're putting on our sample mean, if you will, adding and subtracting it, z sub alpha over 2 times the standard deviation divided by the root of the sample size. Well, what if we wanted to find the sample size? Well, we could do this. Remember, the E there is called our error, and that will be a certain amount that we will decide ahead of time, a margin of error, if you will. It's possible to rearrange this formula, and I'm not going to bother to do it. It's not that involved, but it takes a little algebra. And if you rearrange this formula for N, or sample size, you end up with you know what, I'm going to use theirs, but I'm used to using brackets, but you end up with z sub alpha over 2 in the numerator times the standard deviation divided by the amount of error which we determined ahead of time, and then the whole thing is squared. So this is just a plug-in exercise. We're going to set an amount of error at the beginning, and I'll explain that, and we're going to be at a certain z sub alpha over 2, which involves our confidence, our percentage of being confident, and then we're going to have a given standard deviation, and we're also going to square whatever we come up with, and if there's anything left over, we always round up. So here's a perfect example here on example 7.4. It's on automobile thefts, and it says a sociologist wishes to estimate the average number of car thefts in a large city per day within 2 automobiles. So the sociologist, he or she, wants to be correct within 2 cars of the cars stolen per day. That's the error, okay? And the other information we know, it's a he wishes to be 90% confident. So the moment, 99% confident, the moment we hear 99% confident, we think of the z sub alpha over 2 value of 2.58. Now, the sociologist knows that the standard deviation from the previous study was 4.2 cars per day. I just lost my pen again. Okay, so we've got everything we need to set this question up here. Now, what we're looking for, recall, is in. How big a study do I need? And by how big a study, I mean how far back do I go with the number of cars stolen over a period of time. I don't know why I keep losing my pen. Wait a minute. I just talking and thinking here. We're looking for the number of cars. You know, I really apologize. I'm going to have to, I keep losing my pen here. But what we're looking for is the number of cars round up to, excuse me. I should have gone back and specified with the question here. The sociologist wants to be 99% confident, and from a previous study, the standard deviation was found to be 4.2. How many days, the days are which we are talking about, there were a certain number of thefts per day. He wants to be within 2 cars with the amount of thefts, and we want to know how many days should he select to survey. Okay, so recall that what we're really looking for was the average number of car thefts in a large city per day within 2 cars. Okay, so when we get an answer here, we're going to be looking at a period involving days. Sometimes it's a little bit harder to find out exactly what they're looking for, but basically we're surveying our N will be the number of days of records that we need to go through. So here's the formula again. Man, I hope I can finish this. This pen is just, sometimes there's something with this program that makes it difficult, and the pen starts writing with a mind of its own. Z sub alpha over 2 times standard deviation divided by our error. Well, I'm just going to set this up and hope I can, since this is the last one. So we know our Z sub alpha over 2 is 2.58, and we know our standard deviation was 4.2, And we know our error was 2 when we're talking about the number of cars. He wants to be within 2 cars per day. And when they work this out, which you, oh, I forgot the square there. My bad. All right, when they worked this out, and now my pen seems to be almost back, they ended up with 29.35 days. But we have a rule that whenever we're going for sample size, that we don't break the unit down. We just always go up to the next quantity. In this case, the next quantity would be 30 days. So the sociologist would have to go through the records of the past, or a 30-day record, to answer his question. Oh, and just to remind everybody, at the very bottom of page 7, on page 377, they tell us in most cases in statistics we round off, but when we're determining sample size, we always round up to the next whole number. Okay, well, I apologize about my pen here and getting a little wrapped up in the wording of the question, but I've given you a couple of sample size questions to do. You'll have a sample size question on the Chapter 7 quiz, and you'll have a sample size question on the Chapter 7 test review and on the Chapter 7 test. I'll be back shortly with 7.2. Thank you.